Hello, I'm Paul Hutton, editor of Smart Highways magazine. We're just getting ready to show you another session from JCT Traffic Signals Symposium 2018. But before, let me just remind you of a few things. First of all, if you're at JCT this year or are affiliated to the organisation, you can sign up for a free copy of Smart Highways magazine. Just go to the link at the bottom of the screen. Also, mark your cards for the ITS UK Summit, 26th and 27th of November at the Bristol Harbour Hotel. It will be a fantastic day talking about implementation. And next year, don't forget, Trafex, 2nd to 4th of April. It is the biggest and best Trafex yet. Don't miss it.
Now it's my pleasure to invite Ian Caruana from Suffolk County Council. He's an ITS engineer with a communications background, and he likes travelling to Austria. So we have quite a few travellers in this session. Nigel Fairfield is also going to support him in the presentation, and Nigel has a background in systems support and works for DINIC, and he's a registered football coach and enjoys cycling. So over to the two of you to talk about Lowestoft Bascule Bridge, multiple data source and control strategy.
Thank you, Margaret. Okay, morning. It's Ian Caruana, ITS engineer from Suffolk. Here today to talk about the Lowestoft Bascule Bridge. The title there, I'll explain where that's come from, a little bit of background to that. Bascule Bridge in Lowestoft, it actually raises and lowers to allow vessels to pass underneath. During that process, there's various data bits are generated. We detect those data bits, and we have a strategy that sees the data bits being generated, and as at various stages during that process of it raising and lowering, the strategy then triggers various things to happen out on street. So hopefully that explains where the titles come from. The strategy that we use is actually DINIC's WebOS software that we use to write the strategy. I should explain that we'd already taken that on board prior to this project coming along, so it wasn't this project that drove that decision. That's something we took in-house and felt. Sorry, I'll try and speak up a little bit. Is it too quiet?
It's a mic.
Is it?
It's my fault. Bit of a Britney Spears moment.
All right, is that better? Everyone hear me? Sorry. Okay, yeah, sounds a bit louder now. Yeah, so we use DINIC's WebOS software for writing the strategy, and that was, decision was taken within the team quite a while back. It certainly wasn't driven by this project, it's the platform we had at the time. Okay. For those who don't know Lowestoft, there's two routes go north and south in Lowestoft. The main one is closest to the coast. It's this one here, which is the A12. That's the trunk route going up. Both bridges in Lowestoft raise and lower, to allow vessels to go underneath them. There's a tidal flow system on the bridge that we're concerned with, the one shown in this image here. It doesn't actually affect the presentation too much. It adds complications on site, but from the point of view of this presentation, it's not particularly relevant. There is a scoot region. You can see there where I put the diamonds, that's actually junctions, and the crosses there, that's pedestrian crossings. And at this point, I should do a thank you to Green Signals. Green Signals did setting up the scoot region for us, so thank you to that. The thing that drove this project was safety concerns by the Port Authority that operates the bridge, and obviously to a lesser degree there was also congestion concerns as well. Okay. The objectives was driven by the Port Authority requirement to us to try and stop the people jumping the wigwags. When the wigwags were coming on, people obviously knew the bridge out for quite a long while, and therefore there's quite an incentive, if you like, to try and jump them. And obviously that was something the Port Authority was desperately trying to stop. There was also a desire on our part to try and manage the traffic flow as best as we could, whilst the bridge is up, which is obviously a tall order anyway, but as best as we could. And then once it's back down again, we wanted the traffic to flow as freely as possible and clear the town centre. And there was also a third desire for us to actually inform motorists approaching the bridge that the bridge was raising and they might have an opportunity to take an alternative route. Right, the solution that we come up with, I'll go through a quick overview before I go through it in more detail. We worked with the Port Authority to identify control bits at various stages of the bridge raise and lowering. As the bridge, it's a hydraulically driven bridge. So there's various things. Out on street, you will see obviously the bridge go up. You'll see the wigwags come on. You'll see the barriers come down. You'll see the bridge raise. Then obviously, once it's time to go down, the bridge goes down. The barriers go up, and then the wigwags come off. There's also other things going on in the background that aren't seen, and we use those to trigger various things. The bits are detected from that. We wanted to use the very first opportunity we had to detect the bridge going up, and the thing that we got there was obviously, as I said, it's a hydraulic bridge. So we used a bit from the pump, and the pump triggers up, starts up. We get a bit generated from that happening. And by using that bit, we was hoping to hold the traffic back at the junctions, north and south, prior to the wigwags being triggered. Okay, that's and what we did was we put an all red on both junctions with just green exiting the bridge. And the third part of the solution was we wanted to display some messages on some VMS signs that we had up at Lowestoft, the Suffolk VMS signs, and we was going to display a message there to inform drivers of alternative routes. Once we've done that, we then need to detect that the barriers are down, and we're going to trigger an X plan, because once the barriers are down, the north and south traffic that doesn't want to go across the bridge, we're trying to get as many movements as possible there. The X plan for that time of day is usually reverts it back to scoot. Okay. Once the bridge was back up, we needed to detect that as well. And what we did was we ran a clearance plan for 3 minutes, which was controlled from the strategy for a 3-minute period of time. And we also put a message out to clear the VMS signs, so that they blanked the VMS signs. Here's a flow chart. I'll go through it in a bit more detail now. So as the bridge operator pushes the button, so as vessels approaching the bridge from the Port Authority, the operator there pushes the button. First thing that starts is the pump. That generates bit 27. Now, the third box down there, you see WebOS is checking for bit 25, maintenance bit. The first thing we realised is that actually, when the guys are working on the bridge controller, they can generate all sorts of bits. So the first thing we needed to do is actually get a maintenance bit. So if the door was open and they was working on their controller, we needed to stop the strategy, so the strategy didn't write. The last thing we wanted to do was start changing things on the street based on spurious bits being generated by someone working on the controller, on the bridge controller. So we put a check there for bit 25, which is the maintenance bit. Assuming bit 25 wasn't detected, WebOS would then detect bit 27 from the pump start bit, and that would trigger fixed time plan 5, and it would send a message to the VMS signs. Fixed time plan 5 would be the all red north and south of the bridge, just with green exiting the bridge. The next thing that WebOS would detect, there's various things going on the street, but the next thing that WebOS is looking for, because it's only the triggers that we're interested in that we're looking for, is the barriers in the down position. And the thing we see there, we lose bit 27, so we detect bit 27 going off. When WebOS detects that's going off, it then triggers the X plan. WebOS detects bit 27 off, then triggers X plan.
Which hands it back to Scoot.
Yeah, which hands it back to Scoot, that's it, so we're back on the Scoot. Right.
Sorry, and can I just say, the reason we do that, because we don't know how long the bridge is going to be open, so we hand it back to an adaptive algorithm to handle that traffic while the bridge is open.
Right, cheers Nigel. Bridge operator then pushes the down button once the vessel's cleared. Once the bridge is down, the barriers go up, the wigwags go off, and then we lose bit 8. Bit 8 goes off. Once we've lost bit 8, we then, WebOS obviously detects that, and we then run a clearance plan, which gives the main drag and try and clear the main drag out. And we run that, that's got a fixed timer in WebOS for about 3 minutes. Well, it's not about, it is 3 minutes. Now, I wasn't quite honest in the last slide, because I was saying WebOS actually interprets the bits, but this is the real world, and that's what we expected to happen. But actually, when we got there, we couldn't get WebOS to detect the bits directly. So Nigel came up with a very inventive way of doing it. We created we created a virtual controller on TMS, and the virtual controller interpreted the bit coming from the bridge controller. The virtual controller ran a dummy plan, and what WebOS was looking for is it was looking at the dummy control or the virtual controller, and it was actually reading the dummy plan. And it's what I've called a bit translation service. But as with all workarounds, you then end up with another workaround that you have to do, and the only problem is we need to detect more than one bit at the same time. Obviously, a controller can't run 2 plans at the same time, so the way we got around that was to create a second virtual controller, and that seemed to solve the problem. This is what the strategy looks like in WebOS. If you not familiar with WebOS, the green boxes are basically situations, and the yellow boxes are responses. The situations are where you're looking for something, to detect something, a detection point, and the yellow response boxes are actually making something happen out on the street. If you look at the first box up there, that's actually, I don't know if I can see if I can point to that. No, I can't see it, but anyway, the first box up there, situation, it should be detecting for the maintenance mode. If it detects it's in maintenance mode, it goes around the green loop and does nothing, just chugs around there. If the student doesn't detect the maintenance mode, the strategy drops down to the next box. The next box is now looking for the bridge up bit, which is the pump bit we spoke about. And if it detects that, it goes down to the next level. If it doesn't detect it, it goes around the loop. The next level is the yellow box response, and the response is applying fixed time plans, and it sends a message to the VMS signs. Drops down to the next level and detects the barriers are now in the down position, so it then reverts back to scoot. And then goes down to the further level, and then have temporary X plans are running. Drops down the next level, detects the wigwags are off. If they're off, it then goes down to the next response, which is the bridge clearance plans. And then runs that, then that clock, the last thing there, that's set for 3 minutes. It runs that for 3 minutes, then it reverts back to X plan, which for that time of day is, well, for normal time of day, scoot. I'm not going to spend too much time on this, it's just really how it looks in WebOS. If you have a situation, you click on the green button up there, and just to the right-hand side of the view, and that creates a condition description, and then you get the object property window drops up, and you'll see that we've got the traffic signals is the object, LSJ09, which is the virtual controller we created. It's looking for a plan. It wants that plan to be equal to something. In that case, it's equal to plan 11. So if it sees plan 11, then it will act. This is what it looks like when you click on the response and you want to put response in and you're defining the responses. If you take note, the first one there is a bridge open to traffic. That's actually a message to any logged in users. So if I'm sitting at my desk with WebOS open, I will get a message sent to me saying that the bridge is going up, the bridge is locked in position, the bridge is down again. The other ones are actually telling the LSJ01 all the way down to 7 to actually fire up fixed time plan 13. And then the last one there on the list, you'll see that's actually giving an instruction to clear the screen. Now this is actually an old screenshot because we actually changed it with something else that we did while I was out on site. But this is what I would see on my desk. It tells me the first one says the Bascule bridge has gone up, the next one says Bascule bridge is in locked position, and then it says the bridge open to traffic. Okay, that middle one was actually different because what we actually did when I was out on site, when it was first set up, we actually waited for the bridge to lock in the up position before we actually changed the plan and let the traffic move north and south as best as they could. And we found that actually that was too long, but we actually found another bit was going off when the barriers came down. And once the barriers are down, we've effectively achieved what we wanted to do because no one can obviously jump the wigwags at that point. So we actually changed that. So actually I should change the message on that rather than saying it's in the lock position. It should actually, that middle one should now say barriers are down. Okay. Well, conclusion, well, did we actually meet our objectives? Well, as far as the Port Authority is concerned, and they're the ones who actually gave us this task, the jumping of the wigwags, yes, I mean, it's dramatically reduced the amount of times it's done it. It definitely holds the cars back before the wigwags kick in. It's not completely eliminated it because we've had a couple of reports where they've still got the wigwags, but it's a massive improvement from what it was, so I'll definitely give a tick to the first one. The second one, improving traffic flow. We've only been doing this recently, but initially it looks as though we have improved it as far as clearing the traffic out, and I think we're doing the best we can with the scoot plans thanks to green signals for getting this, getting the clearing stuff out and for moving the traffic around the north and south junctions. Now the last one, unfortunately, we've had a few hiccups with. As I say, this is the real world, and as with everything, there's problems are thrown in front of us. But informing drivers of the bridge raise. We was actually testing this with a Swarco sign that we had spare in our staff car park actually, and we got it working. But then when we transferred it to the signs that we've got up in Lowestoft, unfortunately we couldn't get it to work. So as we speak at the moment, the VMS messages are not actually going out on street, but I've got a challenge with Dinnock to try and sort that in the next couple of months, because I'm unfortunately not going to be around for a couple of months, and when I come back, if JCT is happy with me, I'd like to give everyone an update on that final point, if you could point that out. Okay, John? Thank you. So that's where we are with that. And I think the only other thing on the VMS that we've got to do is actually the user can't actually see a graphical. You've just got the coding of it. You don't see a graphical image on your desktop, which is something else that Dinnock's working on. So that's it. And then finally, last but not least, thank you to Swarco. I haven't spoken on this, but I know that didn't have to liaise between the two to get the two things to work. So thank you for working behind the scenes with Dinnock for me. Green Signals, obviously you've spent quite a bit of time up there, so thank you to Green Signals wherever you are. Obviously Dinnock, I think Nigel's sick of the sight of me, and I'd like to give a thank you to Melvin Maycock at the Needham Market Depot as well. That's it. Is there any questions, please?
Well done, Ian.
Thank you very much, Ian. Any question over here?
Hi, Helen Kanzik from Transport for London. I like your setup, it's very similar to Tower Bridge that we use. What I'm interested in, and I know it doesn't work, but the driver information, how far away from that junction are you intending to provide that driver information in order to keep people completely away from that crossing when it's open?
The VMS signs that we have were placed many years ago, not part of this project. So some of them are not ideally situated. But yeah, we've probably got sufficient. I've worked out it will take about 10 to 15 minutes. I'm assuming, I'm not a boat person, but I'm assuming just looking at the distance and knowing where they've got to go. Because you've got to bear in mind, there's two bridges in Lowestoft, and there's no point going to the other bridge if the other one's up at the same time. So yeah, they're far enough out to actually get to the second bridge prior to what I think a vessel would get to the second bridge, if the second bridge was going to be used, because not all vessels go through the two bridges. A lot of them stop at midpoint. But I think there's sufficient time for the outer signs to enable drivers to make an alternative route, if that's the case. The other thing with Lowestoft, it is right in the town centre, so some people coming in to shop, it may well be that they decide, actually, do you know what, I know how bad this gets when that bridge is up, I'm just going to park here and walk the last little bit. So there's that as well. But I can't give an exact answer because these signs were put in not as part of this project. We just thought we can do this as an add-on to what we're trying to achieve here. Okay.
Further questions? Perhaps then, could you elaborate a little bit more on your evaluation? You know, you said there was less red light runners, presumably. But,
yeah.
You know, what have you done in terms of evaluating?
We rely very heavily on the Port Authority. We've got quite a good relationship, haven't spent so much time up there with them. But the actual guys looking out the window, watching what's going, and they're the ones that reported that they've told us this problem, and they've made it quite clear, because they do actually keep a report. We haven't got the actual documentation there, but they do keep a report of all safety concerns regarding, you know, jumping the wigwags, because there's serious implications. And they have made it quite clear to us anecdotally that at the moment that is a massive improvement. But yeah, I could get the figures and I could circulate those as well.
No, really, what about the, you know, the actual influence of the traffic?
Right, the influence of the traffic, that's harder to actually determine, to be honest. It appears, it's anecdotal if you like, it appears to be working better, but we've only actually really done this in the last couple of weeks. I think I was up there 2 weeks ago for the line bit, but it does a case of going up there and actually checking, and we might have to tweak a few bits, but it seems to improve things.
It is Scoot, though.
It is Scoot, yeah, most of the time it's Scoot.
Because there may be something in Scoot, you know, data from Scoot as a
we could take it from there, yeah.
You could probably look at the
we could,
on delay.
We could actually get it from there as well, yeah.
Yeah. Okay. Further questions? Okay, well, thanks very much indeed for fascinating.